Hello and welcome. So you might have seen that the FMWC Financial Modeling World Cup has just put out a new Excel esports battle. So in just under 2 weeks, I'm going to be facing off against some of the great and the good of the modeling world. There's all kinds of superstars here. So it's been a lot of financial modeling around here lately, but now I need to get in training, get my problem solving skills back up to scratch. So that's what I'm going to be doing the next couple of weeks. And I thought I would start with this one here, which was a semi-final problem from the Battle of 16 last September, I guess. Oh yeah, there it is, September. Which I did not do particularly well on, so I thought it might be a good one to do some training with. It's also a nice, interesting problem, and it's a good one to demonstrate a lot of different techniques around text functions. So here's the challenge. You're given a word maze, which is a 20 by 1000 grid of letters, numbers, and a few symbols, and you're given a bunch of words that you have to find in there, with all kinds of twists. The first twist is that a question mark symbol can stand for anything. So in the demonstration I give you here is that this WA question mark LY is a match for Wally. So that's the answer for each word is what square does it start in. So for example here, I know there's another one here. It says good luck right there. So the answer for this one would be B14. The answer for this one is B13, and so on. So a few different levels. At level 1, there are 10 words to find, and they all read left to right, so just like this one here, Wally. At level 2, there are 7 words to find, and they can read either left to right, like that, or top to bottom, like that. Then level 3, they can go any horizontal or vertical direction. So in other words, it can go from right to left, it can go from bottom to top, or it can go from left to right, or it can go from top to bottom. And then at level 4, it can also go in any diagonal direction. So it might be something like this. It could be up to the right, up to the left, down to the left, down to the right. And then at level 5, it's a snake. So each next letter could be adjacent to the previous letter horizontally or vertically in any direction. So in other words, a valid word might be something like this: EQIDOG 2K4KR, or something like that. Needless to say, that one's pretty hard. So that's the challenge. Let's dive right in, and I'll try and do some kind of explaining as I go. So first things first. Well, let's start with just a kind of somewhat easier way to tackle the first one. So the first thing we're going to want to do, we're only interested in reading left to right. So a good start would just be to combine all of these into one string that we can search in, and it's easy to do that with concat. If you're still one of the poor sad people that doesn't have the newer versions of Excel, then you can do this the way we always used to for so many years, which is just build it up one cell at a time. So just do that, and then this and the next one, and then copy across, and you can see you're adding one letter at a time, and you gradually build it up. But those are, compared to now, those are the bad old days, and it's much easier to just do it with concat, and then we can copy that down. So we've got 1020 character strings. And so then we want to figure out, let's say, which one of these strings does FMWC appear in. And so what we can do is we can say match, and what we're going to do is match with a wildcard. So in other words, if I say match FMWC against here, it's not going to be there because these are all 20 characters long, and that's only 4. So what I'm going to match on is a star, meaning any, asterisk meaning any set of characters, followed by FMWC, followed by any other set of characters. I'm going to match that on this list here, and 0 for an exact match. And that tells me in the 596th row of this. And actually, since I'm interested in returning the cell address, so for example, this one here, Wally, is in B13, I'm actually better off to do that match on the whole column. So I'll just do that, and then it tells me it's in row 608. So let's go down to 608. That's here, and sure enough, there we can find FMWC. So now we need to figure out which column that comes up in. So how do we do that? So you could do it with a few helper cells, or again, if you've got new Excel, then you can do all the pieces together with match. So first I'm going to say the row number is that match, so that's 608 is my row number. And then let's say my row string can be index column V row num, and let's just output row string so we can see that. So that's now giving me that whole big string that I want to find FMWC in. So then I want to find, let's say, string match is going to be search. You can use search or find. Search has the advantage that it is not case sensitive. So if there were, I don't think there are, I think there's only uppercase letters in the grid, but if there were lowercase letters, I would still consider lowercase FMWC a match, and so I'm going to use search because it won't be case sensitive. So I'm going to search that in my string match. Sorry, no, in my row string. And then let's see what that gives me, and then I'll need to turn this all into an address. So that tells me it's in the 9th one. So let's just go back down to 608. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so then I just need to convert that ninth character here into a column number, into a column letter actually. So what I'm interested in is column J. Now J is the 10th letter because there's one empty column here. So basically I need to turn that 9 into the 10th letter, which is J. So a quick sidebar, I think I've done this in some of my videos before, but if you want to switch between letters and numbers for things like getting to the next letter or anything like that, a good way to do it is code and char. So code gives you the ASCII code, I think, or Unicode code, I'm pretty sure it's ASCII code of any letter, and char gives you converts a number back to a letter. So in other words, let's see, if we just say that +1, copy it down a little, the 65th character is uppercase A, 66th is uppercase B, 67th is uppercase C, 68th is uppercase D, and so on. And so here I want character of, let's see, 9 on the 10th letter, so 64, 65 plus my string match, and then I want to concatenate that with my row number, and that gives me J608, and I can quickly, I've got my my score tracking here live linked to the answers, so I know I got it right, but quick way to check if you don't have that. Let's go to J608, and sure enough, that's the first cell of FMWC, so that's good. And now that we have done that, I'll just clear these out, we can copy this down, and hopefully get the rest of level 1 out. And sure enough, that gets me the 100 points for level 1. Now, the challenge with this is you got to figure out a way to generalize it to the top to bottom, the left to right, the right to left, and the bottom to top, and the diagonals. The diagonals are the trickiest ones. So you might think you could fairly easily just kind of apply this same method to columns to get the top to bottom. So let's just try that quickly. Obviously, the way I'm phrasing it will probably give away that it's not quite going to work the same way. So here's my 20,000 character strings that represent the whole column. So for all my vertical words, I'm going to want to find them in there. Actually, I guess one quick aside is that now that you've figured out how to find left to right words, there could still be left to right matches in any of levels 2, 3, and 4, so it's worth just copying that down. Anything where it NAs out, I'll just wrap it in an if error. Say nothing. But you can see that gives me one match for horizontal there, and it gives me one match for finance there. So, even though I've only actually solved level 1, I can pick up 20 points from level 2 and 30 points from level 3. And, if things are tight, that can make a difference. Now I'm on 150 instead of 100. But, so now, anything that doesn't match in level 2 is going to have to be vertical. So, for example, harder is going to be in one of these. So, I could do the same thing as I did first time. I'll just do a kind of demo here. Match harder against that 0. But now it gives me an NA error. And this kind of threw me for a loop the first time I saw it, because I don't know if it was on this problem or a different one, but I had this situation where I knew harder had to be in there somewhere, or the equivalent to harder had to be in there somewhere, but I couldn't find it. So I did a little bit of testing. So let's just do something that we 100% know is in there. Here's a substring of that column, and let's just match star and that and star against here. So we definitely know it's in there, exact match, and it gives us, moving that out, it gives us an NA error. And the reason for that, if you go and dig around a bit, is basically a wildcard match on any string that is longer than 255 characters doesn't work. Even if you're matching, let's say, the first few letters, I could say match this and that against this 0. And even though I'm matching the first few letters of the string, it's very easy to see it matches, but match says no match. So that's just something to be aware of, because it won't necessarily, like, it doesn't say anything about, hey, I can't search I can't search a wildcard in a string that long. It just says NA exactly the same as it says when it's not found. So that's something to be careful of. A little weirdly, sorry, let me just put that back. A little weirdly, countifs does match it. So if I say countifs that this and star, that matches. And if I go back to having some string from down toward the end of it, not even in the first 255 characters, if I match star and that, I still get a 1. And so you could do a kind of workaround to basically, to figure out, all right, which one of these does harder come in? Well, I could say, let's just put star harder star here. Then I could say bicol this array. And so the bicol just lets you apply a formula to each column. And since I'm only applying it to a row, it's basically applying it to each cell. And my formula is going to be lambda. So that the function I'm going to apply is the function that says count how many times x matches the pattern star harder star. And that, you'll see, shows me I've got a 1 here, which is my match in column I, 0s everywhere else. And then I could match a 1 against that, 0, and it tells me it's in column 8. So that's a kind of a workaround that you could do to still be able to match against that, but you can see it's getting more complicated. When you get on to the next level, where you need to be able to reverse it, it's slightly but not massively more complicated, because it's not too hard to like concat the reverse of this string. But this method, by the time you get to the diagonals, you've got to shift the grid if you want to be able to concatenate across it. And the more layers of complexity you add, the harder it is to get from where you matched. Like, let's say you figure out that this cell contains the last letter on some diagonal, but then, if it's 6 characters long, you got to work back to here or here or here or whatever corner for where the word actually started. So, it's not impossible, but it's getting complicated, and sometimes that's a sign that, you're not using the right method. So I'm going to show you a totally different method now, which actually generalizes a lot more nicely to all of the first 4 levels. The 5th level is totally different, but we'll come back to that. All right, so the idea is I'm going to look for just one word at a time. So let's say I start off by looking for Wally, and I'm going to look for one direction at a time. So let's say I start off by looking for left to right. And then basically what I'm going to need to do is I'm going to have a little table of just interpreting my directions. So I'm going to have top to bottom, left to right, right to left, bottom to top, and then I'm going to have 4 diagonals, diagonal 1, diagonal 2, diagonal 3, and diagonal 4. For each of those, I'm going to say what direction is it moving in the row and what direction is it moving in the column. So if you're going left to right or right to left, you don't change the row, you stay in the same row. And for left to right, you increase the column number. For right to left, you decrease the column number. So I'm just putting in the direction of travel. Top to bottom, you increase the row number, no change in column. Bottom to top, decrease the row number, no change in column. And then the 4 diagonals, I've got 1, 1, 1, minus 1, minus 1, 1, and minus 1, minus 1. And then I'm going to have my active one here. I'm going to look up whatever I've selected here, in here, returning from here. And then I'm going to have a row offset and a col offset. And those are going to be, I'm going to have, so basically what I want to have is, starting from, a given cell, let's say here, I'm going to have first take that cell, so offset 0, 0, then take, let's say, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, out as far as however many letters I have here. So first, let me get a sequence that's the right length. So I want sequence that's the length of whatever word I've selected. So right now it's going to be 5. It'll change later. No columns, and I'm going to start at 0 because I want to start with 0 offset. And then I'm just going to take this, lock in the column, hash times this. And so now, if I, for reading left to right, if I take the cell that's 0 rows, 0 columns away from the current cell, then 0 rows, 1 column, 0 rows, 2 columns, 0 rows, 3 columns, 0 rows, 4 column, and I put those all together, I will get a word that is the word that you get reading left to right 5 characters from whatever place I start. And then basically what I'm going to do is I'll make a grid of 20,000 words. You know, what is the word you get when you start in this cell and read 5 characters left to right? And then I'll just check if that matches my pattern. Now, I originally planned to do this with offset, which is, I guess, why I had thought of structuring the offsets this way. And then, for whatever reason, when I tried to do it, it didn't work. I'll show you just briefly. Let's do this. Let's say concat. Maybe some of the wizards out there who use offset more often can tell me what I'm doing wrong. But what I tried to do was offset from, let's say, W, and then I'm going to go this many rows. Oops, sorry, went too far. This many rows and this many columns. Concatenate that, and it gave me a value error. And when I go to evaluate, it just throws all values. I don't understand why, but anyway, you got to pivot when something goes wrong. So instead of using offset, I just decided to use index. So the one challenge with index is I need to index in a fixed range. So in other words, if I want to offset from here by 5 cells, then I need to have a selected range that's 5 cells wide, and I might need to go left, I might need to go right. So this also required me to figure out what's the furthest I might have to go. In other words, what's the longest word? So let's just check that and do max len this. So the longest word is 12 letters. So I need basically to have 12 empty spaces here, above and to the sides. That's 10 by 10, 11 by 11, 12 by 12. Okay, so I'm going to take my grid and put it here. And yeah, let me just, I'll actually put the grid here. Sorry, just value paste, and I'll take that width and put it over there. And then I need 12 empty columns over here as well. So basically I'm going to take an index in a 25 by 25 area around this, around like this particular cell, say, so that using index I can go, you know, diagonally all the way up here, or vertically, or diagonally, or horizontally, or whatever. And then I'm going to put them all together. So let's do that. So I'm going to index on this 25 by 25 box, and then my row number is going to be it's going to be 13 plus this row offset. So I'm going to lock that in and then put the hash, so it selects the whole lot. And then my column number 13 plus my col offset, and again put the hash, so it picks up the whole column. And that gives me exactly that. And I can concat those together. And that gives me WA question mark LY. And then if I take this, copy down and right, it'll take a second, but I can handle it. And you can see at the end here, I've only got 1 character, 2 characters, 3 characters, because, you know, reading left to right from here, you just don't have 5 characters. But that's fine, because, you know, 1 or 2 or 3 or 4 characters will never match the pattern of a 5 character. So now I could just say, you know, that equals my target word, and that would give me, let's just put a minus minus in front of it so it turns into 1 for yes and 0 for no. And that would give me, let's just pick a different word quickly, one that does not have a wildcard. So let's try FMWC. And let's see, I can't see where it is, but that is not showing a match. That's Sorry. Supposed to be. All right, well, let's try good luck. I saw good luck was right here in the second row, so let's try that one. So what do we got? Good luck, exclamation mark. Ah, sorry, I didn't lock. God, it's this tiniest, stupidest things that kill you. I didn't lock in the reference. Okay, so we'll try that again. And so we can see that gives me a match for good luck there. I'll talk about how to get it back into a cell reference in a second. But now let's go back to Wally, because that one is not a match, even here, because we're trying to match Wally with a question mark to Wally without a question mark. So rather than just doing equals to allow for the question mark, I'm instead going to do a countifs. Count how many times we match that pattern. So I'm going to say countif, where this word matches that pattern. And that then gives me a 1 for Wally because, oops, sorry, went too fast. Because Wally does match the pattern WA question mark LY, because question mark is what countifs uses as a wildcard for a single character anyway. If it didn't, we'd have to do a find replace to fix that. But anyway, so then I want to convert this into I want to convert this into an address. So to do that, I'm going to use my code and char to give me labels across the top here. So the first column is B. So I'm going to want a sequence of characters, which is 20 columns wide, starts at 60, so 65 is A, so I'm going to start at 66. I don't need a step. That'll give me BCDDD, or you could just type these across. It's not massively slower. So then I'm going to say if countif, you can say if countif greater than 0, but 1 is treated as true, 0 is treated as false, so just if countif also works. Then I want this and the row number, otherwise blank. So that gives me B13 there, and nothing for all the others. And then I can just concat, put them all together, and there's just B13. So that's the address for that cell. And now we basically need to make a table to work out all the different permutations of this we might need. So I'm going to do a filter because these are all in 2 cells each. So first, let's just go like this. And then you can see this gives me all this mess with zeros. So we'll just filter this where that just in column W is not equal to blank. That's my words. So I want to test all the level 1 words just left to right. And that this is where this kind of setup comes in handy, because now it's very easy to generalize. So I want to test all of these words left to right and also top to bottom. And then set 3. I want to test left to right, top to bottom, top to bottom. Sorry, where did I? And then also right to left. So I should settle down. So make these all R to L, make these all bottom to top. And then I need to test these in 8 different directions, which, let me just do that slightly more efficiently than what I was doing before. So index, got my 8 different directions listed out here. So let's do that, and then let's make this equals that plus 1. So 2, 3, 4, 5, 6, 7, 8 different directions. Okay. So then I can just copy, value, paste that. Then I just need a row, let's say 1, and then I'm going to make this be index this and this row. Oops. And the reason I'm doing it that way is just because I need, for the table, I just want there to be only one variable rather than two. So now, I'm searching for Wally left to right, but now I could press 2 and that'll search for FMWC left to right. I can press 65 and that'll search for challenge something, challenge top to bottom, and so on. Oh, whoops, I shouldn't have put anything here because I'm in the spill range. So we have up to 12 characters, so I need to leave 12 blank. So let's move down below that range. Oops, that was a lucky spot. All right, so then I just need to get my answer from over here. Oops, sorry, over here. I think it was in that cell. I need one that actually contains the answer. So let's just go back to 1 for a second. Yes, good, B13. So then I just need, how many rows are there? 109. So I'm going to do this column. So again, data table, I've talked about this before, but it's just saying, put this cell into here, this cell into here, this cell into here, 3, 4, 5, 6, and give me the result of this cell in each of those. Now the first thing I'm going to do is just turn off automatic table calculations, because that's a little slow, but not super slow. It seems to have got a good way down. And then we'll, and then we'll recalculate. And it's showing me data table 1. It's working. And it's done. So now you can see I've got all these different things here. I'm just going to move this down to line up with it, just because then it's a little easier to see which words are for which. So in other words, Wally, B13, FMWC, J608, and then when we get further down, there are misses, and that's because, there's no match for harder left to right, but there is a match for harder top to bottom. So to get to the answers, I'm just going to say equals concat if, sorry, where are we here? So if the word is equal to this thing, which is W15, then give me, where are we? Then give me this, otherwise nothing. And then if I string all those together, as long as there's only one match, I should be good. And so that'll hopefully, and then all in one go, complete the first 4 levels. Let's just check. 730. I thought I was only supposed to have 700. Maybe the points added up funny on this one. Okay, yeah, I guess the points added up to more than 1,000 by mistake. Or maybe this got changed later, I don't know, maybe these were supposed to be 90. Anyway, fine. So I've got all those right. Now, let's talk about the last one, because the last one is a totally different beast, and you won't be able to do it like this. So a few different approaches. I mean, one thing just as a purely tactical point, so, a couple of people I think it was Dan Mayo and Bill Jellin hosting this one on the live stream, they pointed out as a couple of tactical things. One that I kind of glided over earlier is that, I've set it up to handle wildcards, and in this case, that wasn't a big lift. It was just a countif instead of an equals. But depending on your methods, handling wildcards might be a lot harder. So it's worth thinking in advance about how many wildcards are there. Now, quick, trivia fact: if you search for a question mark, you're going to find lots of matches, because remember, a question mark is a wildcard for any character. So what you need to do is search for tilde question mark, which means I literally want a question mark, not a question mark as a wildcard. And then you can see 1, 2, 3, and that's it. There are 3 question marks in the whole grid. So actually, just manually dealing with cases that error out if you handle everything except a question mark would have been a pretty reasonable strategy here. But the other interesting tactical point was that there's only 3 words here at the end, and they've got big point values each. So in other words, I think I narrowly won this round with a score of like 220. Basically because I stuffed it up. So I almost got levels 1 and 2 and didn't get level 3 or 4 at all. Had something I was working on, but it didn't come through. Anyway, it doesn't matter. But so in other words, you could have won the round on that day just by getting these 3 words. And so if you have a method that's like super manual, but you could find one of these words in 10 minutes by doing it, then that could still have been a winning strategy. So I'm going to show you quickly two methods, one that I came up with and one that somebody else suggested. So firstly, whatever the direction it kind of twists and turns in, if you want to have, snake, then you're going to have an S somewhere, and then next to it an N, and then next to that an A. In other words, you're going to have an N where the 4 cells around it include both S and A. And that's a basis for a decent filter to kind of get you down to a searchable space. So let me just show you how you might do that. I'm just going to paste it over here. And then I'm going to say equals and. Let's say this character equals N. And then, yeah, and then I want any of the surrounding characters, B12 equals S, or this equals S, or this equals S, or this equals S. And then the same thing, any of the surrounding cells has to be A. So if you just do that, oh, sorry, let's put a minus minus in front of it to convert it to ones and zeros. You can see the sum is 8. You've got 8 partial matches there. So you can pretty easily say, let's just search for 1, where we search by values, and then you can just check the individual ones. So I'm looking for something around J210. Whoops. And I can come over here and I can say, yeah, I see SNA, but there's no K around it, so move on. And, in a few minutes, you could go and check each one. And there's a couple here together around J335. So that's here. And again, you can see SNA or SNA, but no K is available there. So, a couple of minutes there, and you can find it, and then, you update this to replace it with the letters you're looking for difficult or for winner or whatever. So that's one method, pretty manual, but it would work. And then another method someone suggested in the comments on the live stream is to format the cells based on letters included in the word. So I'm going to say equals not is error. In other words, there's a match. Search B13 in, let's just try it on difficult. Is here. That's already locked in automatically, so that's fine. Close, 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 and format, let's just turn it orange. And then you can see you're going to need to find a pretty big cluster like this. And again, it's not super fast, but if you scan down through this, you could pretty quickly work out, okay, I haven't seen it so far, etc., etc., etc. Now, they might have anticipated some version of this because as it happens, the answers are all kind of down toward the end. But, you can see these clusters, but it's pretty easy to scan visually and see, okay, that doesn't contain the right letters in the right order. And then, oh, here we are, DIFFICULT. And you're done. So it's H940 is the answer. So, two pretty interesting ways to kind of hack it there. But as you know, I like to be systematic about things. So let's talk about a systematic way to crack this one. And this is another fun excuse, since Excel is a programming language now, to use a lambda, recursive lambda in particular. So think about the logic we want. We want to know, does the word snake, let's say we want to know, does the word snake start in this cell? Well, first we're going to say, is there an S in here? Or if you want to handle wildcards, I don't think there are any wildcards in the snake ones, but there could have been. So, first you want to know, is there an S in here or a question mark? And then you want to know, does the word nake start in one of the 4 surrounding cells? And so it's not hard to see the sort of logic for a recursive lambda to write there. So let's just write that quickly. So I'm going to write a function, loading system, what are you taking? Editor? I don't know why this is loading so slowly. I'll just write it in the name manager if I have to, but it'll be easier to write it in here because it's pretty handy editor. This, by the way, I'm just using the advanced formula environment, which is a friendly place to write lambdas. Okay, so here we go. So I'm going to write a function called word search, and let's expand this so I can take advantage of the whole formula editor. So what's it going to be? I'm going to say lambda. I'm going to take two parameters. I'm going to take a start cell and a target word. Okay, and then what's my logic? I'm going to say first if the start cell is not, so the start cell is the cell I want the word to start in and then snake out from there in some way. So if the start cell is not compatible with the word, then we're just done. So if either I forgot you can't move this out of the way in the way that you can with the formula bar, so hopefully that's to come in a future edition. But anyway, if either the what do I call it, start cell is equal to left the tab behavior is a little different as well. Takes some getting used to, but that's fine. So either it's equal to the first letter of the target word, or the start cell is a question mark. If either of those is true, then we have, one thing. But if they're not true, then we want to. So I'm just going to return true or false according to whether this particular cell starts this particular word. So if it doesn't contain the first letter of the target word or a question mark, then the word does not start here. If it does, then the next piece of logic is going to say if the target word is just one letter, then we're done. So if len of target word equals 1, then we're going to return true. And then this is where the magic happens. So we're now in the case where the first letter is a match, either because it's a question mark wildcard or because it's an actual match. But there's more letters to come. And so now we want to say, basically, we want the rest of the target word to appear starting in any of the 4 surrounding cells. So I'm going to make that an OR. And I'm going to lay out, oh, it's already nicely indented that for me. So I'm going to word search. So my start cell is going to be offset from the old start cell. And we'll start by going 1 row up, 0 columns. So that's that. And then my target word is going to be mid. I just want everything except the first letter of target word. So I'm going to go 2 len target word. And that's my recursive call in one direction. And then I just need the same thing in all 4 directions. So I'm going to have one where I go down, one where I go up, one where I go left, and one where I go right. I'm going to click tick, refresh, and then we will. It's taking a weirdly long time to sync. I don't know why it's taking so long to do that. But anyway, whenever it is good and ready. Okay, there we go. I think we're in sync now. So let's just do a test. We'll word search here, looking for Wally, and we get true. If I copy it down, it's false on the other cells. Now let's try it on something a little more complicated. Let's say word search starting on this cell. Can it find W exclamation mark 0 Y D W D M O Y? Oh dear, I think that was supposed to be there. Let's see. Did I get that wrong? W exclamation mark. Sorry, I need to put this out somewhere I can see it. I can't tell if my function is broken or I just made a mistake with the example. So W exclamation mark 0 Y D W D M O Y. Shoot, something is not working. All right. Dang. All right. Let's try a simpler example again. Let's try my good luck. Here, that's true. I'm just going to try going straight to the finish line, and if it doesn't work, I'll do a little more debugging. So we'll come over here, and then I'm going to say if word search, and sorry, let's put my word up here. Let's say I'm starting with snake. If word search E13, which is the first cell of the grid, target word, if that returns true, then I want, do I have my A's, B's, C's written down here somewhere? I don't. So let's just say car 65 plus, no, 64 plus column of that, and row, otherwise blank. And then I just need to do my 25,000 grid of that. Copy down and across. Take a second to calculate. And then let's see if it found something. And it did. J793. So let's take that, pop it in. 793. Then difficult and winner are the other two words. Difficult. H940, which is where we found it earlier, so that's good. H940. And finally, winner. Oops. Q888. Q888. And let's just kind of check these quickly visually. So here's my J793. I've got SNA, no, maybe SNAKE. So that one works. Then what was it? H940. We looked at that one earlier. So let's go Q888. And I should have WINNER. Good. So that seems to be working. And let's see, did I get the points? I did. Okay, cool. So I don't know. Maybe I made a typo in that when I was testing, but in any case, it seems to have worked on the ones I needed it to. So another fun chance to use a recursive lambda and feel a little bit like a computer programmer. I'm not sure that I'm yet at the stage where I would have the confidence to use a lambda like this in the competition, because if it does go wrong, it's a little challenging to debug. But I feel like I'm getting there. The logic for this is relatively simple. It was relatively quick to write compared to almost any other way that you could try to solve that level 5. I think it's pretty efficient. Anyway, that's all I've got for today. Like I said, I'm going to be doing various other problem-solving questions. I'll probably look back at the old Battle of 16, FMWC Open, and maybe some of the esports style questions from the Financial Modeling University Championship as well. If there's anything in particular you would like to see me tackle over the next couple of weeks, let me know. And yeah, I'll see you next time. Thanks.